A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Herman, I was thinking about the Unix Epoch this morning while I was waiting for my coffee to brew. We treat it like this ultimate foundational truth of the universe. January 1st, 1970, at midnight, UTC. It is the 0 point for almost every piece of software we use. But the more you look at it, the more you realize that the Unix Epoch is a convenient lie we all agreed to tell ourselves just to keep the digital world from collapsing into total chaos. It is a social contract disguised as a timestamp.
It is absolutely a lie, Korn. It is a mathematical abstraction that assumes time is a neat, linear progression of seconds, completely detached from the messy reality of how humans actually live and how the Earth actually moves. Herman Poppleberry here, and honestly, this is one of those topics that keeps me up at night. Our housemate Daniel actually sent us a prompt about this recently, specifically looking at how this rigid, Gregorian-centric architecture of modern computing smashes right into the wall when it encounters the Hebrew calendar. It is like trying to fit a hyperdimensional peg into a very flat, very square hole.
It really is a clash of civilizations, but written in code. On one side, you have the Gregorian calendar, which is what most of the world uses for business, and then you have the Unix timestamp, which is just a big integer counting seconds since that arbitrary midnight in 1970. On the other side, you have the Hebrew calendar, which is lunisolar, astronomical, and highly location-dependent. It is not just a different way of naming months, it is a fundamentally different philosophy of what a day even is. And today, March 8th, 2026, we are right in the thick of it.
And for those who might have missed our deep dive back in episode 734, where we talked about the illusion of coordinated universal time, today is the natural evolution of that conversation. We are moving from the wobbles of the Earth's rotation to the structural friction of how we organize years and months. The Hebrew calendar is beautiful because it tries to harmonize the lunar cycle with the solar cycle using a 19-year Metonic cycle. But that harmony is a nightmare for a developer who just wants to call a simple date-time function in Python or Java.
Let's break down that Metonic cycle for a second, because I think people hear 19 years, and their eyes glaze over. In a standard Gregorian setup, we have a leap day every 4 years to keep us aligned with the sun. But the moon does not care about the sun. A lunar year is about 11 days shorter than a solar year. If you do nothing, your holidays start drifting through the seasons. The Hebrew calendar fixes this by adding an entire extra month, 7 times every 19 years.
Right? It is the Adar 1 and Adar 2 solution. In years 3, 6, 8, 11, 14, 17, and 19 of the cycle, you just insert a 30-day month. We are actually in year 6 of the current cycle right now, which is why this is so relevant. But think about the logic gate there. In a Gregorian system, a year is a predictable length with one minor variation. In the Hebrew system, the very structure of the year, the number of months it contains, is variable. If you have a database schema that assumes a month column is always an integer between 1 and 12, you have already failed. You have built a system that cannot legally or culturally function in Israel.
And that is just the yearly view. When you zoom into the daily view, the sunset problem is where the real technical debt starts to pile up. In the standard software world, we assume a day starts at midnight. It is a clean digital break. But in the Hebrew calendar, the day starts at sunset. And not just sunset as a general idea, but the precise astronomical moment the sun disappears below the horizon at your specific latitude and longitude.
This is the core conflict. Most modern operating systems and databases are built on ISO 8601. That standard is the backbone of global commerce, but it is deeply structurally biased toward the Gregorian system. It assumes that a date is a global constant for a 24-hour period starting at midnight. When you introduce a system where the date changes based on a local astronomical event like sunset, you are not just changing a label, you are breaking the underlying logic of how databases index information. If you and I are standing in Jerusalem and our friend in New York is looking at the same server, the Hebrew date might actually be different for us for several hours every single day.
I mean, think about the complexity of geolocation here. To accurately determine a Hebrew date, a piece of software cannot just look at a clock. It has to know your precise coordinates to calculate the exact moment of sunset. We have seen projects like the Headcall API try to solve this, but it requires a level of contextual awareness that most standard libraries just do not have. If you are writing a banking app, you do not usually ask for the user's GPS coordinates just to figure out what day it is. But if you do not, you might record a transaction on the wrong Hebrew date, which could have legal ramifications.
It goes even deeper than just sunset corn. In Jewish law, there is this period called Bein Hashmashat, or the twilight period. It is the time between sunset and when three medium-sized stars appear in the sky. During this window, it is technically neither day nor night, or rather, it is both. How do you code for both? If a child is born during those 20 minutes, their birthday, their bar mitzvah date, and even their legal standing in certain religious contexts depends on how you resolve that ambiguity. A Unix timestamp is a single point in time. It has no concept of twilight ambiguity.
That sounds like a nightmare for a developer trying to use a standard library like Python's datetime or Java's java.time. Those libraries are built on the assumption of a chronology object, and while they technically support non-Gregorian calendars, the support is often thin. They usually treat the Hebrew calendar as a simple mapping exercise. Take the Gregorian date and find the Hebrew equivalent. But they often ignore the sunset offset entirely, defaulting to midnight because that is what the underlying OS expects.
If you use the standard Hydra or Hebrew chronology in Java, it often just maps the Gregorian day to the Hebrew day 1-to-1. It ignores the fact that from 6 p.m. to midnight, the Gregorian and Hebrew calendars are out of sync. This is what I call calendar colonialism in code. We force these ancient, complex systems to behave like the Gregorian one just so they fit into our pre-existing classes and methods. But in doing so, we lose the very essence of the calendar.
So, if the standard libraries are failing us, how does a country like Israel handle this? I mentioned the law of the use of the Hebrew date from 1998. It is a fascinating piece of legislation. It requires the Hebrew date to be on all official documents, government correspondence, and even checks. You cannot just opt out of the Hebrew calendar if you are a bank in Tel Aviv.
You really can't. And this is where the wrapper architecture comes in. Israeli banks and government agencies do not try to rewrite the Linux kernel to understand the Metonic cycle. That would be suicide. Instead, they build these incredibly sophisticated abstraction layers. Imagine a standard SQL database. At the bottom layer, everything is stored in standard UTC timestamps. That is the source of truth for the machine. But sitting on top of that is a middleware layer that contains the astronomical algorithms for the Hebrew calendar.
So, when a clerk enters a date, the middleware is doing the heavy lifting.
Precise. If a clerk in a bank in West Jerusalem enters a transaction at 5:30 p.m. in the winter, the middleware looks at the GPS coordinates of that branch, calculates that sunset was at 4:48 p.m., and tells the database, this transaction happened on the 1st of Shislo, even though the Gregorian date is still the previous day. The database stores the UTC timestamp, but it also stores a metadata tag for the Hebrew date. This allows for dual indexing. You can search for all transactions on a specific Gregorian day or all transactions on a specific Hebrew day.
But the indexing is where it gets tricky, right? If I want to find every contract signed in the month of Elul over the last 10 years, the database has to do a lot of work because Elul does not map to the same Gregorian weeks every year. It jumps around by weeks.
It is a performance nightmare if you do not index both. If you only store the UTC timestamp and try to calculate the Hebrew month on the fly for 1,000,000 rows, your query will take forever. So, these systems end up with fat rows, lots of redundant data just to make the calendar logic searchable. And then you have the edge cases of interest calculations. This is something we touched on in episode 586 when we talked about high precision timekeeping, but it takes on a new life here.
Right, because if a financial contract is based on a monthly interest rate, and suddenly a year has 13 months instead of 12, because of Adar 2, who pays for that extra month? Or if a loan is due on the first of the month, and that month is Adar, does it mean Adar 1 or Adar 2?
The Israeli legal system has had to step in where the code fails. Generally, if a contract says Adar and it is a leap year, it defaults to Adar 1. But from a technical perspective, your interest calculation engine has to be calendar aware. You cannot just divide the annual rate by 12. You have to check the is leap year flag for the Hebrew calendar specifically. If you use a standard financial library from a US-based company, it is almost certainly going to get that wrong. It will assume 12 months, and you will end up with a massive reconciliation error at the end of the 19-year cycle.
It makes me think about the comparison with the Islamic Hijri calendar. We see similar issues in Saudi Arabia and the Gulf states, but the Hijri calendar is purely lunar. It does not have a leap month to stay in sync with the sun. This means the months rotate through the seasons every 33 years. From a coding perspective, that is actually simpler because you do not have the 13-month year, but it is harder for long-term planning because Ramadan might be in the blistering summer one decade and the cool winter the next.
The Hijri calendar also has the observation problem. Traditionally, the start of the month is based on the actual physical sighting of the new moon. You cannot code for a human being standing on a hill in Mecca looking at the sky. Some countries have moved to calculated calendars, like the al-Qura calendar, to make it computer-friendly. The Hebrew calendar, thankfully for developers, has been based on a fixed calculation since the 4th century. Hillel II gave us an algorithm, and as long as there is an algorithm, we can build a bridge.
And that bridge in Israel is increasingly becoming the national time server. This is a project I have been following. The idea is to provide a standardized digital pulse that includes the Hebrew date context. Instead of every individual server in the country trying to calculate sunset on its own, which can lead to variations based on which atmospheric refraction model you use, there is a central authority.
That is such a vital point, Korn. Atmospheric refraction. If it is a particularly humid day, the sun might appear to set a few seconds later than the geometric calculation suggests. If two different banking servers use different models, they might disagree on the date for a few seconds every day. The national time server solves this by broadcasting a definitive, the Hebrew date has now changed, signal. It moves the source of truth from the local machine to a centralized, legally recognized authority. It is like the atomic clocks we discussed in episode 721, but instead of just syncing the seconds, you are syncing the cultural and legal reality.
It really highlights the second-order effects of these systems. If you are a global company like Google or Microsoft, you cannot just ignore this. If your calendar app crashes because it cannot handle a 13-month year, you lose the Israeli market. I remember a few years ago, there was a major OS update where the calendar widget would just go blank if you switched to the Hebrew view during a leap year. It was a classic off-by-one error, but on a massive national scale.
I remember that. It happened because the UI logic was hard-coded to expect a maximum of 12-month objects in an array. When the 13th month appeared, the array index went out of bounds and the whole process killed itself. It is a perfect example of why we need the ICU, the International Components for Unicode.
Let's talk about the ICU for a minute, because that is the unsung hero here.
It really is. The ICU is a library used by almost every major operating system: Android, iOS, Windows, Linux. It is the repository of all the world's weird calendar rules. It contains the Metonic cycle math, the Hijri observation rules, the Chinese lunisolar calculations, and even the Coptic calendar. When a developer uses a high-level function to get current date, they are usually tapping into ICU. But the problem is that most developers do not know how to use the advanced features. They just call date.toString and hope for the best.
And toString is where the context goes to die. If you store a date as a string like 1st of Adar, and then 5 years later you try to figure out what Gregorian day that was, you might realize you did not store whether it was a leap year or not, or which Adar it was. You lose the temporal resolution. This is why the gold standard is always store everything in UTC timestamps at the database level, and only convert to the local calendar at the very last second in the presentation layer.
That is the mantra. But even then, the conversion itself is fraught with peril. If the ICU library gets an update with a more accurate sunset model, your historical data might suddenly shift by a day when you view it. It is a reminder that our digital record of history is only as stable as the algorithms we use to interpret it. We touched on this in episode 1032 when we talked about ancient backups. The Hebrew calendar is one of the oldest backups of human timekeeping, and we are still trying to find the right drivers to make it work with our modern hardware.
It is a fascinating tension. We are trying to run an ancient operating system, one that has been running for thousands of years in a virtual machine on top of Unix. The friction is inevitable. But I think there is a broader lesson here for all of us, not just the coders. We tend to think of the world as being increasingly standardized and uniform. We have the same internet, the same smartphones, the same global economy. But time is one of those areas where deep cultural roots still dictate the architecture of our lives.
And that is especially true here in Jerusalem. You see it every Friday afternoon. The transition from the work week to the Sabbath is not just a change in mood, it is a structural shift in how the city functions. Elevators go into Sabbath mode, public transport stops, and the digital pulse of the city changes. And that shift is dictated by the sunset, by the Hebrew calendar. If your phone does not understand that, it is not actually helping you navigate your reality. A smartphone that thinks Friday evening is just more Friday is failing its user in this context.
It brings us back to the idea of context-aware computing. We are moving toward a world where software needs to understand not just what you are doing, but where you are and what cultural framework you are operating in. For Israel, that means the Hebrew calendar has to be a first-class citizen in the world of code. It cannot just be an afterthought or a plugin. It has to be baked into the way we think about temporal abstraction layers.
So, for the developers listening, what is the practical takeaway here? I mean, besides, don't hard code 12 months in a year.
I think the first step is to stop assuming time is a scalar value. When you are designing a system that will be used globally, you have to treat time as a multifaceted object. You need to use libraries like ICU that are designed for internationalization from the ground up, and you have to be incredibly disciplined about your data storage. Store the raw UTC, store the offset, and if you are dealing with a specific calendar like the Hebrew one, store the location data that was used to generate that date. Without the context, the data is incomplete.
It is also a reminder of the importance of testing. You cannot just test your app for the next 6 months and assume it works. You have to test it against leap years, against different locations, and against the specific edge cases of the Metonic cycle. We have seen so many systems fail because they were only tested in a Gregorian vacuum. If you are building a subscription service, what happens if someone signs up on the 30th of Shislu, a month that sometimes only has 29 days? Does your billing engine just skip them, or does it crash?
These are the weird prompts that keep us going. It is not just a technical challenge, it is a philosophical one. We have to accept that our global consensus on time is a fragile thing. It is a social construct that we have built to facilitate trade and communication, but it is not a physical constant of the universe. The moon and the sun do not care about our Unix timestamps. They follow their own rhythms, and the Hebrew calendar is an attempt to stay in sync with those rhythms while still maintaining a functional society.
It is funny, we often talk about how technology is supposed to make our lives simpler, but in this case, it feels like it is just revealing the underlying complexity that was always there. Before computers, if a check had a Hebrew date, a human teller would just look at it and understand the context. Now, we have to teach a machine to have that same level of cultural intuition, and that is a much harder task. We are trying to codify tradition, and tradition is notoriously resistant to being turned into an if-then statement.
And as we look toward the future, this problem only gets bigger. Think about off-world colonies. If we eventually have a base on Mars, a day, their Sol is about 40 minutes longer than an Earth day. The Gregorian calendar will be completely useless for a Martian colonist. We will have to invent entirely new calendar systems, like the Darien calendar, and we will probably run into the exact same friction with our Earth-centric software. Imagine trying to sync a Martian database with a Unix epoch based on Earth seconds.
Oh, I have already started looking into the Martian epoch problem. It is going to be the Hebrew calendar problem, but on a planetary scale. We will have to decide if we want to stay Earth synchronized or if we want to let the Martian environment dictate our time. The Hebrew calendar chose the environment, the sun and the moon. Modern computing chose the machine, the fixed second. The tension between those two choices is where all the interesting bugs live.
It also reminds me of our conservative worldview in a way. There is a respect for tradition and for these ancient systems that have sustained a people for millennia. We do not just toss them aside because they are incompatible with a new piece of software. Instead, we do the hard work of building the bridges between the old and the new. We find ways to make the ancient wisdom of the Metonic cycle live alongside the cutting-edge precision of an atomic clock.
That is a powerful point, Korn. It is about integration, not replacement. We are not trying to fix the Hebrew calendar to make it more like the Gregorian one. We are trying to make our technology sophisticated enough to handle the richness of human tradition. It is a more difficult path, but it is a much more rewarding one. It forces us to be better engineers.
And it is a path that Israel has had to lead the way on. Out of necessity, Israeli engineers have become some of the world's leading experts on nonlinear timekeeping and complex calendar integration. They have turned a legal requirement into a source of technical innovation. It is a great example of how a specific cultural constraint can actually drive better engineering. If you do not have to worry about leap months or sunsets, you might never think to build a truly robust time-handling library. But when the law says you must, you find a way.
And for our listeners, I hope this gives you a bit more appreciation for that date on your phone or your computer. There is a massive amount of hidden infrastructure and thousands of years of astronomical observation sitting behind those numbers. It is not just a clock, it is a bridge between the stars and the silicon. When you see March 8th on your screen, just remember that for millions of people, the day actually changed hours ago, and the machine is just finally catching up.
Well said, Herman. I think that is a perfect place to start wrapping this up. We have covered everything from the Unix Epoch to the Metonic cycle, from Israeli banking laws to the future of Martian timekeeping. It is a lot to take in, but it really highlights why we call this show My Weird Prompts. These are the kinds of deep technical and cultural intersections that we love to explore.
And if you have been enjoying this journey with us, whether you are a new listener or you have been with us since the early days, we would really appreciate it if you could leave a review on your podcast app or on Spotify. It genuinely helps other curious minds find the show and join the conversation. We are closing in on our next milestone, and every rating counts.
It really does. And remember, you can find all our past episodes, including the ones we referenced today, like episode 734 on UTC and episode 586 on high precision timekeeping, over at our website, myweirdprompts.com. We have a full archive there, and you can even send us your own weird prompts through the contact form. We read every single one of them.
We are always looking for the next deep dive. Thanks to Daniel for sparking this one, it was a great excuse to finally talk about the sunset problem in a real-world context. It is something we deal with every day here in Jerusalem, but seeing it through the lens of software architecture really brings it home. It makes you realize that even the most objective technology is still a product of human culture.
Definitely. It makes me look at my watch in a whole new way. Well, that is it for today's episode of My Weird Prompts. I am Corn Poppleberry.
And I am Herman Poppleberry.
Thanks for listening, and we will see you in the next one, whenever that happens to be, depending on your calendar.
Until next time.
You know, I was just thinking, Herman, if we ever do get that Mars colony, we're going to have to do an episode on the soul versus the day. I hear the Martian year is 687 days long. Imagine the leap year logic for that.
Oh, I have already got a folder of papers on the Darien calendar. It uses a 24-month system to keep the months roughly the same length as Earth months. It is going to be a nightmare for the developers, but a dream for us.
I expected nothing less. See you at home, brother.
See you there.
And to everyone else, thanks again for being part of this. We really value this community we have built over the last 1,000+ episodes. It is your curiosity that keeps us digging into these rabbit holes.
Stay curious, stay skeptical, and keep asking those weird questions. The world is much more complex than the default settings on your phone would have you believe.
Signing off from Jerusalem. Peace.
Peace.
Wait, did we mention the review pitch?
Yeah, I think I got it in there. But it never hurts to remind people. A quick rating on Spotify really does make a difference for an independent show like ours. It helps us climb the charts and reach people who actually care about the difference between a lunar and a solar year.
Good point. All right, now we are really going. Bye, everyone.
Goodbye.
One last thing. I just realized that next year is a leap year in the Hebrew calendar. We should probably check if our own website's RSS feed handles Adar 2 correctly. I would hate for our episode to disappear into a temporal void.
Oh, don't worry, I checked the code for the feed generator last month. We're using a robust library that handles the Metonic cycle perfectly. I even ran a simulation for the next 100 years.
Of course you did. I should have known you would have a simulation running.
Trust the donkey, corn. We have it under control. The bits are aligned with the stars.
I always do, Herman. I always do. All right, let's get some dinner before the sun goes down and the day changes on us. I think there is a place nearby that does a great shawarma, and they definitely close at sunset.
Lead the way. My internal clock says it is exactly time for tahini.
This has been My Weird Prompts. Thanks for listening. Find us at myweirdprompts.com and on Spotify.
See you next time.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow